Okay, this is problem 6.9 out of Griffiths' Introduction to Quantum Mechanics. If you like this video, please give it a thumbs up and subscribe. It helps me. And I'll keep posting more videos with solutions from quantum mechanics, other physics, and math books as well. So 6.9 says, under parity, a true scalar operator does not change. Oops, didn't mean to do that. Meant to highlight it. Whereas with a pseudo vector, the sign does change. And then it wants us to show those two properties, the commutation relation and the anti-commutator. So just to summarize, parity, dagger, acting on some scalar, should just give it back. So this is a real scalar. And if it changes signs, so if we get this, it's a fake scalar or a pseudo scalar. Okay. So the trick to doing this is so first off, we want to show that the commutator is equal to 0 for a true scalar, and the anti-commutator is 0 for a pseudo scalar. So for a real scalar, essentially what I'm going to do is I'm going to move this over just a little bit. Well, I'll leave the definition. I'll just rewrite it. So we have pi dagger f pi equals f. And now I'm just going to have parity operating on either side. And the important thing to know, and I think I've talked about this in other videos, is that pi dagger is equal to pi dagger pi, which is just 1. Okay? So using that property, this is just 1. So we have f pi equals pi f, or subtracting it over, pi f minus f pi equals 0, and this is nothing more than the commutation relation for parity and this scalar f. Okay, so that was the first part. The other one is to look at a pseudo scalar. So the pseudo scalar tells us this. I'll just draw it a little closer. And same idea. We're going to have parity operating on like this. And we still get 1. Now we have f pi equals minus pi f. The negative is just a constant. So f pi plus pi f is the anti-commutator, but you could also write like this because it's equal to 0, so no biggie. So okay, that was for part A. Part B, it's the same thing, but instead it's a vector v, and if it gives you negative your operator back, that's a true scalar, or a true vector, I'm sorry. And if it doesn't change signs, then it is a fake vector. It's a pseudo vector. Yeah, just making sure. And really, it's the same exact idea. Pi operating on dagger v pi equals minus pi v. Again, this is 1. So you get v pi plus pi v, which is equal to the commutator of v pi, which is equal to 0. Okay, so that is this part for a true, and for a fake it's just backwards. So again, pi dagger v pi equals just pi v. And of course you get pi v minus v pi equals 0, which is our commutated relation for parity and this vector v. And that's part B. So really, as long as you know is that pi dagger is 1, and you remember these relations, then it's quite straightforward. I mean, they give it to you in the homework. So yeah, that's how you do the problem. Hopefully it helped, and if it did, please like and subscribe.